What are C++ cross-platform challenges for robotics software? Imagine building a robot that can work anywhere, from a factory in Tokyo to a research lab in Berlin. Now picture making that robot software run smoothly across all those different places. That's what cross-platform development in C++ for robotics is all about. It sounds simple, but it actually involves many tricky parts. First, robots come with all sorts of hardware. Some have different sensors, motors, or joint setups. Writing code that controls all these variations is tough. Developers need to create an interface that hides these differences, so the same code can work on different robots. But designing such an interface is complicated because each robot might use different units, communication protocols, or control schemes. For example, one robot might use degrees for joint angles, while another uses radians. Translating these differences requires extra layers of code that can be error-prone. Next, the operating system on which the robot runs adds another layer of difficulty. Some robots operate on Linux, others on Windows, and some use real-time operating systems designed for precise control. Each OS has its own system calls, device drivers, and development tools. While C++ itself is portable, the libraries and system dependencies often are not. This means that code written for one OS might not compile or run correctly on another without modifications. Concurrency is another challenge. Robots often need to do many things at once, like processing sensor data, controlling motors, and communicating with other devices. C++ supports multi-threading, but different platforms handle threads differently. Processor architectures vary in core counts and scheduling policies, which can affect how well multi-threaded code performs. Ensuring that tasks run smoothly and meet real-time constraints across all platforms requires careful planning and testing. The software ecosystem also adds complexity. Many robotics libraries are written in different languages or target specific platforms. Combining C++ with languages like Python or Rust can cause compatibility issues. Building and linking these libraries across different systems can be a headache because build systems and data formats differ. This fragmentation can slow down development and make it harder to share code. Debugging and deploying software on various hardware setups is another hurdle. Embedded systems or real-time controllers often lack user-friendly debugging tools. Remote debugging, profiling, and updating software across multiple platforms requiring specialized tools, which may not be equally mature for all systems. This can make fixing bugs and optimizing performance more difficult. Finally, standardization plays a big role. Without common interfaces and data formats, porting high-level behaviors from one robot to another becomes a manual process. Developers need to create universal APIs for sensors, actuators, and control algorithms, but this takes time and careful design. Without these standards, reusing code across different robots is error-prone and inefficient. To overcome these challenges, robotics engineers focus on designing modular software with clear hardware abstraction layers. They use cross-platform build tools and libraries that isolate platform-specific code. They also adopt concurrency patterns suited for real-time systems and leverage community-supported frameworks that promote portability. Investing in robust testing and debugging tools that work across platforms is also key. Understanding these cross-platform hurdles in C++ helps developers build more reliable, flexible, and maintainable robotics software. It's all about making sure that no matter where the robot is, its brain can handle the job smoothly.